there's no questions, what we're doing today is operations, polynomials and operations. So we're going to be looking at addition, subtraction, and multiplication. We're not going to do division today. We'll do it tomorrow and Friday because there's two different ways we can do division, and we're going to look at each one of those individually and kind of break it down. Now, when we look at addition and subtraction, there's two ways that we can do it. Really multiplication too, but we'll only look at one way with multiplication. We'll look at two with addition and subtraction. Now the first one is we can add vertically, up and down. So we can put our first polynomial expression first. So 3x squared, not squared, 3x cubed plus 2x squared minus x minus 7. Now, if there is a gap, and what I mean by gap, I mean if we had a term missing. So the biggest term we have here is x cubed. So if we had x cubed but didn't have x squared, we had x and then we had our constant term 7, I would leave a space where the x squared was supposed to be. That way, if the other expression has x squared, we don't try to misalign terms and try to combine things that are not like terms. Kind of make sense? So if there's a term missing, we can leave a gap for it. Now the other one, we have x cubed first, so I'll put it under the x cubed. And the negative 10x squared, I'll put it under the x squared. But do we have a term with x? No. So I'm not going to put the 8 under the x. I'm going to put the plus 8 under the 7. So I left a gap under the minus x, because the other expression didn't have an x term or a number multiplied by x, so we left it blank. And the same thing would be true for the top one. If it had a spot where we didn't have a term, we can leave a little bit of a gap, so if the bottom one does, we don't misalign it or combine unlike terms. And we're going to add. And I put the symbol, the plus sign, all the way through it, so I know that I am adding all of these here. It doesn't make as big of an impact with addition, but with subtraction sometimes, especially if they get big polynomial expressions, we have 6 terms. I've seen it, I've done it, I've seen students do it. They'll get about halfway through to 3/4 of the way through and stop subtracting and start adding. It's just, we're adding, subtracting, so we just start combining terms. So I put this here as a reminder, okay, we're adding all the way through here. Or if we were subtracting, we would do the same thing. Now we just combine like terms, we add. So 3x cubed plus x cubed is 4x cubed. We'll move to the next one, 2x squared plus negative 10x squared. Now the next one is our negative x plus, well, we don't have anything to add to it, so we just bring it down, it's just negative x. Negative 7 plus 8 is plus 1. Now, especially with subtraction, if the negative x was second minus negative x, it would change to plus. So we do need to be careful with some signs just in case. But that's it. And you all have done this before. You've done this in Algebra 1, combining like terms, adding, subtracting like terms. But that's it. Questions on this here? Now we can also add horizontally. Now adding vertically is probably not something you've done because not a lot add vertically. We normally add horizontally. Because we normally add them like this here. This is normally how we add things together. Because you've added vertically, but it's probably been since elementary school that you did that way. Now with this here, we're adding them. Because they're both plus or positive in front of both, we can really just drop the parentheses. Well, we can say plus negative 5y squared or just minus 5y squared. Combine like terms. So 9y cubed is by itself. but we do have 3y squared and negative 5y squared. 3y squared minus 5y squared is 2y squared. We also have negative 2y plus y is negative y. Negative 2 plus 1 is negative 1. And lastly, we have 1 minus 4 is negative 3. Questions on this here? Now, you're probably wondering what I wrote or why I wrote the symbols underneath it. For this here, it's not bad because we've only got 1, 2, 3, 4, 5, 6, 7 terms. I do that there to keep track of the like terms. Because when we get bigger polynomials, because we're multiplying, if we multiply these together, 3, 6, 9, 12, we end up with 12 terms. And trying to keep the like terms together or making sure they're accounted for, I do this here. Pretty much I make the symbols to match up to the like terms. That way also when I'm done, if we had 12 different things being added and subtracted, I can easily look through the whole thing and see, is every term accounted for? Are they all combined? Because if I look through and see one of them doesn't have anything underneath, that means I didn't actually add or subtract it in, and I can go back and fix that easily. Also, if it's looking like the numbers down here aren't working out in one of the spots, I can easily look back and see, okay, well, the squares don't add up correctly. Okay, so each one that has the same symbol, I can easily pick through and find them all. So again, that's nothing, something you have to do. That's just my personal preference on how I keep track of everything. Questions on addition? Do we need to see another example of addition? I feel comfortable with this here. Subtraction. Subtraction is the one we do have to be careful with because, again, we're subtracting. Now, we can start off, so again, we're starting off with vertical. I'm going to start off by writing the first one first. And again, if there was any spots missing, I would leave a blank or a little bit of a space to take that into account. But here we have every term. Then we can write the second one with its terms matching up underneath. The cubes line up, the squares line up, x's line up, and our constant terms line up. And this time we're not adding, we are subtracting. And I'm going to put my subtraction symbol in each one of the spots. Each one of the sets of terms that we're subtracting. And then we can go on and subtract. So 2x cubed minus 8x cubed is negative x cubed. And again, on these here, addition, it didn't matter, because if we go through adding, we're just combining. But subtraction, I've seen it time and time again, you'll get to the last two or last one and you'll just add. But here, having the subtraction sign does help us, especially if we look at the second one, 6x squared minus negative 3x squared. Well, negative and negative make a. So I can go and change it. So now we have 6x squared plus 3x squared is 9x squared. The next one, negative x minus negative 2x. Well, the negative and negative makes a positive. Negative x plus 2x is plus x. And 1 minus 9 is negative 8. That's it. Questions on any of this here? Ready for the next one? Now we can also subtract this horizontally. But when we do this horizontally, we do need to make sure we apply that negative to everything in the second set of parentheses. Because whenever we have that subtraction sign in front of a set of parentheses, It's being applied to everything inside those parentheses. Now, since there's a plus in front of our first set, our 3z squared plus z minus 4, it's still going to say 3z squared plus z minus 4. But our 2z squared is going to become negative 2z squared. Our 3z is going to become negative 3z. So we have to apply that negative to both. So this here is where having it vertically is nice, because I don't have to worry so much about making sure to distribute that negative all the way through. When we did the subtraction, it did it for us. Now at this point here, we do need to combine like terms. So 3z squared minus 2z squared is z squared. And we have z minus 3z is negative 2z. Well, negative 4 is by itself. That's it. Questions on any of this here? Questions on anything we've done so far? We need to see another example of this here. So if we feel good with addition, subtraction, we can move on. We will move on to multiplication. Now, we can do this vertically, we can do this horizontally. I'm mainly going to focus on horizontal. So we have this here. And again, just like with addition and subtraction, y'all done this before, because we're going to be using our distributive property. So we'll have negative x squared times x, which is going to be negative x cubed. Negative x squared times negative 3 is going to be plus 3x squared. We skipped a few. Found it? Give you a second to catch up. We good? Now we're just going to continue on doing the same thing. So we'll do 2x times x, which is going to be plus 2x squared. And 2x times negative 3 is negative 6x. And then last but not least, we'll do the same thing with 4. 4 times x is going to be plus 4x. And 4 times negative 3 is negative 12. Combine like terms. So negative x cubed, well, 3x squared and plus 2x squared is plus squared, plus 5x squared. Negative 6x plus 4x is 2x minus 12. Every now and then they will throw these on the ACT for addition, subtraction, multiplication, just for some of the problems. And I would say as you're doing all these, because a few of you are in the ACT prep class, as you solve them, I would always keep an eye on the answers, especially ones like this here. Because as we started working with it, okay, we see that negative x cubed is a part of our final answer, yes? So any answer choices that did not have negative x cubed in it are gone. Okay, we have the next one, okay, 5x squared. Any of them that don't have negative x cubed plus 5x squared are gone. And there's a good chance that you can get at least that far and have eliminated all the answer choices except for one, and you're done, you don't have to finish. Make sense? So sometimes keeping an eye on the answer choices does help. But any other questions on this here? Let's look at one more with multiplication, and then we'll move on, because I feel like y'all probably getting the hang of this pretty quickly. So here we're multiplying y plus 5 by 3y squared minus 2y plus 2. And again, we're going to use our distributive property. Y times 3y squared is going to be 3y cubed. Y times negative 2y is going to be negative 2y squared. And y times 2 is going to be plus 2y. Now we're going to multiply everything by 5. 5 times 3y squared is going to be plus 15y squared. 5 times negative 2y is going to be negative 10y. And 5 times 2 is going to be plus 10. Now when we combine like terms, we'll have 3y squared. Well, negative 2y plus 15y squared is plus 13y squared. Yes, thank you. 3y cubed. Okay, we got everything correct so far. Now we have the 2y minus 10y, which would be negative 8y plus 10. That's it. Any questions on any of this here? We ready for the next one? Yeah, if you ever need that, just let me know. I feel like we feel comfortable with multiplication, yes? We don't need to see another one? Yes. We can. So we start with negative 2. Negative 2 times 5 is negative 10. Negative 2 times 3x is plus 6x. And negative 2 times 2x squared is going to be negative 4x squared. Now, if we were doing just basic multiplication, what the next thing we would 0 and then move over 1. X times 5 is going to be plus 5x. X times negative 3x is negative 3x squared. And x times 2x is 2x. When we multiply like bases, we add the exponents. And then we add straight down. So negative 10 plus 0 is negative 10. 5x plus 6x is plus 11x. Negative 4x squared plus negative 3x squared is negative 7x squared. And then we have that's it. It's not too bad. Any other questions on this here? We'll do one more. We'll do one of these here. I have 2 on the note sheets. We're just going to do one of them. Now, when we multiply these 3 expressions here, it's not really any harder than what we've already done. The first thing we have to do is pick 2 of them and multiply them together. And it doesn't really matter which two we pick. The two that I would say not to do first are x minus 1 and x plus 5 and how we had this set up. Yeah, because we just need to pick two of them. I wouldn't pick the two that are farthest away from each other because then you're trying to multiply with the one in the middle. So we could do this here. So we'll still have x minus 1. Now x times x is x squared. X times 5 is plus 5x. We'll do the same thing with 4. 4 times x is going to be plus, and 4 times 5 is plus 20. And at this point here, we can combine like terms, which will give us x squared plus 9x plus 20. And if you do have more than one that's being multiplied together, make sure to combine like terms before you do the second multiplication. Any questions on this so far? I'll give you all a second to catch up if you need. Now we can just do this again. X times x squared is x cubed. X times 9x is plus 9x squared, and x times 20 is plus 20x. Then we'll do the same thing with negative 1. Negative 1 times x squared is negative x squared. Negative 1 times 9x is negative 9x. And negative 1 times 20 is negative 20. Combine like terms, so we would have x squared. We have 9x squared and negative x squared, which is going to be plus x squared, yes. We have 20x minus 9x is plus 11x, and then we have minus 20. And that's it. Questions on any of this here? So really multiplying two or more than two is not any different than what we've done. It's just we have to do more steps. And I mean, we can make these quote unquote harder, but that's really just making it a trinomial, 3-term and 3-term, or 3-term and 5, making them bigger. Or instead of having nice whole numbers, we could have fractions or decimals. Doesn't change what we're doing, still same process. It's just the numbers are different or more challenging, quote unquote, to do. It's same process, same thing, it's just the numbers look different. And luckily, especially if the numbers start getting big, we have a calculator that can do the numbers for us. Don't put the variables in, because again, both calculators that we have to have a value for. Any questions on this so far? Now, the last thing we're looking at is this here. Now, these here can be helpful in saving time, but that's really about it. Because the first one, sum and difference of perfect squares. Well, we kind of went the other way in the last chapter. If we know that it was a squared minus b squared, the difference of perfect squares, then it factors to a plus b times a minus b. We can go the other way around. If I see that it's a plus b times a minus b, well, it's just the first term squared minus the second term squared. So really we can go from x plus 3 times x minus 3 to x squared minus 9. And our first example that we have, still on that same page, 4n plus 5 times 4n minus 5. Same two terms, but the signs are different. So really what we're saying is that we take the first term squared minus second term squared. Well, 4n squared, 4n times 4n, it's 16n squared. Minus 5 squared is that's it factored. Now I'm going to erase it and I'll rewrite it. You don't have to rewrite it. Because if we did it the other way, 4n times 4n is 16n squared. 4n times negative 5 is negative 20n. 5 times 4n is plus 20n, and 5 times negative 5 is negative 25. Well, the 2 in the middle will cancel. Negative 20 plus 20 is 0, leaving us with 16n squared minus same exact process, or same, not same process, but same overall method to get there. One's shorter than the other. But for the most part, at this point, I think for most of y'all, you'll end up spending almost as much time doing either way. So it's really picking which one you want. I am not expecting y'all to memorize any of these here, these shortcuts, because you'll use them in here, use them maybe once or twice on the ACT, and then that's about it. You can get there either way about as fast. Now the second one is one of our perfect square trinomials, and it's kind of going off of the a squared minus 2ab plus b squared. And we say minus 2ab because there's a subtraction in the middle. Or really what we're saying here is that we have 9y squared minus 2 times, well, we could say plus 2 times 9y times negative 2 plus negative 2 squared. Well, 9y squared is going to be 81y squared plus 2 times 9 is 18 times negative 2 is negative 36, and we have y. Negative 2 squared is 4. Now, for the most part, that's not too overly convenient because one, y'all are having to remember what the correct form for our perfect square trinomial something times itself, and the fact that the a values decrease, the powers decrease. So 2, 1, 0. 0 is just anything to the 0 power is 1. And b ends up going the other direction. So it starts off at b to the 0 for the first spot, b to the first, b squared. So they increase. And then you would need to know the number setup for it. So it's 1, 2, 1, and then plug it in. Now, the other way to do this is, well, anything squared is really saying that it's multiplied by itself. We can't just square both terms and be done. It's saying that it's 9y minus 2 times 9y minus 2. 9y times 9y is 81y squared. 9y times negative 2 is negative 18y. Negative 2 times 9y is negative 18y. And negative 2 times negative 2 is plus 4. And for this one here, really, either method is going to get you to the same place with about the same amount of time. Questions on this here? Because the next one's setup is really going to be a cubed plus 3a squared b plus 3ab squared plus 3 cubed. That's kind of the overall setup. And then we can apply it to this here, which is really going to get us a cubed b cubed plus 12a squared b plus 4 squared is 16 times 3 is 48ab squared plus 64 is what this ends up working out to be. But again, for something like this at this point for y'all, because again, for one, I've done this problem twice today. So that's one of the reasons I can pull it out that fast. Also, I've kind of worked with these long enough that I can manipulate them in my head and get somewhere close to it. And one, knowing it well enough and doing it twice a day kind of helps. Second, I mean, knowing how to do these in your head is no real advantage because there's enough pieces of technology now that can do these for us, except for the 2 calculators that y'all have. The computer, there are programs that will factor and do stuff like this. So These here, there are nice shortcuts for them. We don't have to know them. And one of the biggest ones with that is the Pascal's triangle, the factor tree. Because this here is used to find those coefficients and useful in actually factoring the binomial or factoring binomials, or not factoring, expanding binomials. And the tree, the way this works is actually kind of neat. You always start with the triangle of ones. So 1, 1, 1. Now going this way and this way, spreading out, we will always have 1. They will expand out as we get bigger. But inside the triangle, here, they add together to give us the next number. So 1 and 1 add together to be 2. 1 and 2 add together to be 3. 2 and 1 add together to be 3. We expand down, so we have 1 and 3, 3 and 3, 3 and 1. So it gives us 1, 4, 6, 4, 1. 4 and 1 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 5 is 4 and 1 is 5. If we wanted to do the next set, we'd have 1, then 6, 15, and you can keep on going. Now, for how this works, so if we, for the 6th row, we're saying a plus b to the 6th. Now, for our numbers, we would have 1, 6, 15, 20, 15, 6, 1. You don't have to write any of this in. But the a terms, so a, the one that goes first, is going to start out to the 6th power. And it's going to decrease by 1. So 6 minus 1 would be 5. Then we would have a to the 4th, a to the 3rd, a squared, a to the 1st, and last one would be a to the 0, which is just 1. So we don't write it in. Now b is going the other direction. It starts off at 0. So here we would technically have b to the 0, which is just 1. Then our next one would be b to the 1st. First goes 0 first, then to the 3rd, 4th, and b to the 6th. Now for us, we can just put plus, 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 plus. Because if b was negative, if it had minus b, we can just take that negative and put it in place of b, and it'll alter the signs accordingly. And that's all we would need to do this here. Because we could have something like 2x minus 3 to the 6th power. So A, we can multiply 2x minus 3 by itself 6 times to figure out what this is, or we can plug it in accordingly. So 2x is A, negative 3 is B. So our first one is 1 times a to the 6th, so 2x to the 6th, plus 6 times 2x to the 5th. Well, b is negative 3, so we have negative 3 to the 1st, plus 15 times 2x to the 4th, negative 3 squared, plus 20 times 2x to the 3rd, negative 3 to the 3rd, plus 15 times 2x squared times negative 3 to the 4th, plus 6 times 2x times negative 3 to the 5th, plus negative 3 to the 6th. Which again, this does seem like a massive thing, but compared to multiplying it by itself 6 times, it's actually significantly smaller. Now 2x to the 6th, well, that's going to be x to the 6th. Because 2, 4, 8, 16, 32, 64. So 2 to the 6th is 64. Now 2 to the 5th is 32. And 32 times 6 times negative 3. I'm going to have to get a calculator. is I could do this, but it's going to take a while. Negative 576x to the 5th. And we could do the next one, 15 times 2 to the 4th times negative 3 squared. It's going to be plus 2160x to the 4th, because that's going to be it. Now the next one, so we would have 20 times 8 times negative 27 is negative 4,320x cubed. The next one we would have is going to be 15 times 4 times 81, which is going to be plus 4,860x squared. Now negative 3 to the 5th, clear, negative 3 to the 5th times 12 is negative 2,916x, and then plus negative 3 to the 6 is 729. Yep. And even as long as that took, trying to do 2x minus 3 times itself 6 times is still going to take a while. And if I did this and had to work it all the way out, I would do it in groups, because if we have 4, you can do them 2 at a time and then do them multiple at once. You don't have to do 2 and then do 2 and rewrite them out. But that is all we're doing